My name is Matt Logan. I'm an Android developer at American Express. I live in Denver. This is my first time up here to GGG Boulder, so thank y'all for having me here. Yeah, let's get started. I'll be talking mostly about test doubles and how they can be used to make your unit tests better. And I came up with this title before I started working on the talk. So I should add that test doubles are applicable not just to unit tests, but all kinds of tests. UI tests, integration tests, what have you. All right. So, quick outline, since this is kind of a long talk. I'm going to go over some general terminology that I'll use a little bit in the talk. Really quickly, not going to get into that too much, test philosophy, but those will kind of be like our guiding principles, motivation for all of our decisions. Different types of test doubles, that'll be really quick. And then some best practices. And to quote Captain Barbosa, they're more like guidelines. And then we'll go into a deeper example, kind of related to Android, but mostly applicable to anything. We'll use Java, but I'll explain everything, so it shouldn't be too unfamiliar if you're not familiar with Java. And then some extra stuff that I forgot to add and wanted to cover. So terminology. System under test is the thing you're testing. It can be a class or usually a method or even one part of a method. A dependent on component is anything that your system under test relies on, usually an object, sometimes like an interface type, but it doesn't have to be. An indirect output is any information that goes out of your system under test that is not through its like public API, if that makes sense. So if you provide a dependent on component and that's like a callback, then the indirect output would be the callback being called, maybe with some extra data or maybe without. Indirect input is pretty similar. It's just any information that comes from one of these dependent on components. I should say dependent on component. You may have also heard the word collaborator in this context. Same thing. And test double, which is the point of the talk. So I'm not going to define that here. These words mostly come from a book called X-Unit Patterns. And I'll reference that at the very last slide. But I think X-Unit is like a .NET testing framework. And this guy wrote this big book and kind of like defined this stuff for everyone, not just .NET. So now we all use it. That was like 2001 or something. So this stuff's pretty recent. It's kind of cool. All right. In the words of Martin Fowler, who writes a lot of stuff about software development, test double is a generic term for any case where you replace a production object for testing purposes. Production object, usually in this case, is going to be one of our dependent on components. And we use test doubles to enable testing if a dependent on component in our production code is unavailable because of our test environment. To ease testing, sometimes you might be depending on something like a web service or a SQLite database that just makes testing super complicated and maybe flaky. And you just don't want to deal with that because it's extra complexity and you don't care about testing that stuff. Improved testing, pretty much the same as the first two. And a common misconception is that we use test doubles and like mock objects just to isolate the system under test. And that is a nice side effect, but I think the first three are the real reasons that we use test doubles. And isolation is good for testing, but that's not really the purpose of test doubles. Test philosophy, really quickly, tests should verify correct behavior or state, depending on who you ask. Allow for safe refactoring, which is the point of having tests that you can rely on, right? If you change any tiny implementation detail and then you have to change your tests, then your tests don't really do anything. Tests can drive good design. That's kind of a nice side effect. Ideally, they should, but not necessarily. They can also serve as documentation. This happens a lot with open source code that I'm looking at on GitHub or something. You look at a method and you're like, what does this do? Hopefully there's a corresponding test that basically explains the behavior in code. And finally, tests should be easy to write. So there's 5 types of testables that we're going to cover: the dummy, the fake, the stub, the mock, and the spy. So first of all, there's the dummy. Dummies are never used, and by never used, I mean that we only use them, so they are used a little bit. We use them to satisfy method parameters or like constructor parameters. Basically, they're placeholder objects. Sometimes we can pass null, but that doesn't give us very much information. So dummies are a little better. Dummies should be easy to implement. You don't want to spend too much time on them. And a dummy can be a primitive or an object. For example, if you're passing an integer to a method in a test and the particular code path that you're testing doesn't use that integer, you might just pass -1, for example. So that's also a dummy. It doesn't have to be an object. But if it is, here's one example. Let's say one of your collaborators or depended on components in a test is something called a location client. In this case, location client is an interface marked by that keyword implements, which is a Java thing. So if you can picture an app on an Android phone that keeps track of your current location, and we're testing some code that interacts with this location client that deals with this GPS stuff. And then you want to run your test on like a CI server or on your local machine. You might not have access to that GPS stack, whatever that is. So you want to come up with an alternate implementation. If you want to use the implementation, you can make another kind of testable. But if you need to just satisfy that location client parameter, you can pass in a dummy. And one small point here that I want to point out is that we throw an exception if anything in the dummy is called. And it can be really confusing if you don't do that. One example, if you are familiar with the Android mockable jar, which is like all of the Android classes except without any implementations. If you're writing unit tests for Android and you don't have like a device or a virtual device available, you need to use this mockable jar if you want to access Android classes, but their implementations are empty. Almost all of them throw exceptions, and it's kind of confusing because they throw an exception and the message is stub, even though I would argue that they're dummies. In one case, though, there's an Android method called textutils.isEmpty, and it tests if a string is either null or empty. And in the mockable jar, that method just returns false. It doesn't throw. And I've seen people be like, why is my test failing? This behavior is so weird. And that's because it was returning false. And the string that they're passing in was not empty. So that's a weird side effect. I recommend that you throw. It's good. Don't just return a default value. Because like the dummy contract basically says, don't call this. So if it's called, you should get out of there. A few more examples. I already mentioned -1. Sorry about the really slow animations on this slide. That was a mistake. If you have to pass a dummy that's a string, you can make it a self-describing value. For example, string that will not be used. That's a very self-descriptive value. Wait for that to fade in. Null is also a dummy, kind of, but it's not very descriptive. And if the test ends up calling something on the dummy and it's null, it'll fail with the null pointer exception, which is not as descriptive as something that you might be able to write in an exception message. Okay, dummies are done. Fakes Fakes are a little bit more complicated than dummies. We basically replace a dependent on component with something that's lighter weight. And by that, I mean it can take shortcuts, but it should still work, and it should be able to be used by the system under test. Fakes can be used for input or output. They're usually hand-coded, or by hand-coded, I mean you write it yourself and you don't use something like Mockito. But there's also like fake code generation libraries. I haven't seen any for Java, but they probably exist. I know they exist in other languages. A good example of a fake is an in-memory database. For example, if the class that you're testing relies on a SQLite database and you don't have access to that in your test environment, since all of your tests will probably run in one process, you don't need to deal with like a file system or a database. So you can just use like a hash map, basically, or hash table. And that as long as it satisfies the contract in the context of your test, then it's fine. Another example is a fake web service. You may have heard of WireMock. There's another one, part of OKHTTP, is a popular Java library. What's it called? Mock Web Server? Yeah, Shuki knows that one. Here's an example of our in-memory database. So it's just a map. Implements location database. The contract is just save and get. And it works exactly like a map. So we just put a map in there and it works, as long as you don't restart the process, which you probably won't in a test anyway. Stubs control the indirect inputs to our system under test. And by that, I mean they give us canned responses. For example, a stubbed HTTP response, or just something that returns false on purpose all the time. You may have heard of VCR. I think it might be for any language, but it might just be a Ruby thing. I've never used it, but a lot of people do. You can basically go through your app and record HTTP responses based on the request. So you like kind of match up the request to the response. And then you can basically play that back in your test. So you're stubbing the responses. It's also a verb, kind of. Here's an example using a stub that I wrote by hand. Say we have this thing called device info, this interface, and a method on it is location enabled. You might see that on like an Android app or an iPhone app. And if we're writing a test where we just want that to return true so we can test some other stuff maybe, we just implement the interface and return true. That's a stub. Here's another example of a stub. This is the exact same thing, except I'm using Mockito to create a stub. Kind of confusing because Mockito uses this method mock. You can also use the mock annotation. But in this case, you're using it to create a stub. But Mockito still calls it a mock. And it's even more confusing because that same method is used to create spies. So that's confusing. Mocks. Mockito actually doesn't create mocks. It creates spies and stubs. But EasyMock creates mocks. That's a Java library you may be familiar with. And the way that you know it's a mock is this keyword expect. So mocks are good for verifying an exact behavior. So you tell the mock exactly what methods you want to be called on it and with what arguments. And then you exercise your system under test. And if those methods that you expect aren't called, then it'll fail, throw an exception. This is good for test-driven development, which I don't really do, honestly. But it kind of makes sense, right? You specify your behavior that you want in a test, and then you do that before you actually write your code. So you do that first, and then you write your code. And once the test passes, you know the code is exhibiting the correct behavior. The downside of mocks is that they can lead to overspecification. The bad thing about overspecification is that your tests become, this is a pretty negative word, but brittle. Basically, if you're testing every single implementation detail of the system under test, then it's very hard to do any refactoring without breaking your tests. So I'll get into that more a little bit later, actually. Mock is also just a generic confusing term for any testable. Mockito uses it, and it's also a verb. You can mock something. Here's an example of a mock. Basically, pretty similar to a spy, which we'll get into in a minute. So you may be kind of familiar with this already. The process is like you just create your system under test, you instantiate your object, whatever that is. You expect something, you call your method, and then if it's not called during the course of the test, that'll throw. A spy, like I said, is really similar to a mock. Sorry to get ahead of myself a little bit there. Spies are a little bit different, though, because instead of expecting something to happen before it happens, you just observe stuff happening, and then after it happens, you verify that it happened. So it's kind of a before versus after. But the APIs between like Mockito and EasyMock are pretty similar. It's just this before and after thing. Spies, in my opinion, are better at showing intent because you can hide irrelevant method calls that happen in the course of a test. And by irrelevant calls, I just mean like implementation details that aren't really part of the behavior of the class that you're testing. A downside, though, of spies versus mocks is that because mocks are more explicit, they're probably a bit easier to debug, whereas spies, you're not really verifying everything, so if you miss something, you might not really understand why your test is failing. But that's not really a great argument against spies. Here's an example. Looks pretty similar to our EasyMock example, except you'll see the spy stuff happens, the verify step happens after we exercise our system under test. By exercise, I just mean call the method. That's pretty similar. Some best practices. These are rules. They're made to be broken. First of all, don't use testables for values. And by values, I don't necessarily mean like integers, ints, doubles. I mean like anything that's like a value type that represents an entity. For example, a location, you can imagine it just has like a latitude and a longitude, or it's just a city name, a place name, whatever. It's probably immutable. Date should be immutable, but Java date is not. Employee, another example. Just create them. There's no reason to use doubles. You don't need anything that doubles provide in this case. For example, there's no reason to verify that an accessor method, for example, like a getter, you don't need to verify that that's called on a value. It doesn't really provide any extra information about the thing that you're testing. One downside to always creating values is that sometimes object creation can be very difficult, especially in the case where you might have some kind of nested object hierarchy that's usually built in like your API client code or something. So you might have some object that has 10 fields and they're all annotated with non-null, so you can't pass null and you don't want to break that. And then each of those fields is an object that has 5 or 10 fields, and then some of those have some more. So you can imagine like this huge nested constructor thing getting really out of hand. Builders are really helpful. Even still, it can get a little crazy. If it gets too crazy, you can also separate your object instantiation logic into separate classes. You can imagine like a bunch of static methods like create employee with this property and this salary, whatever. A bunch of methods. Feel free to get creative with it. This is kind of a general best practice, not necessarily just for testing. Don't use doubles for classes, only use them for interfaces. Interfaces are better at showing relationships between objects. And similarly, like I said, any object should probably just depend on interfaces. Sometimes we can depend on concrete classes. I'm not going to get into why. There's plenty of literature about that. But ideally, you should be able to just extract what you need into an interface and just call that from your system under test. And finally, sometimes we need doubles to be interfaces. For example, that location database example. If we want to hand code a fake implementation of an interface, you can't do that if it's a concrete class. I suppose you could extend it and override some methods, but then there's like some weird state between these two classes that are in this hierarchy, and it gets really confusing. And it wouldn't work for final classes at all. And most concrete classes that you rely on should probably be final anyway, in my opinion. So rely on interfaces, it's better. And finally, don't test implementation details. I kind of got into this earlier, and this is one of the downsides of using a mocking framework like EasyMock. And I'll get into this a little bit further when I bring up my example. But you should ask the question before you write a test, is this a required behavior? So you don't need to verify, you don't need to expect every single method call that happens in your test. Only the ones that actually matter or do anything. If you test every single implementation detail, like I said, you can get brittle tests that you have to refactor and rewrite all the time. And finally, I've said this like 5 times, but refactoring your implementation without changing your public API should never break your tests. And if it does break your tests, then your tests are unreliable, and you can't really use them to give you any peace of mind when you refactor your code. So I'll get into this example here, and hopefully some of the things that I maybe glossed over become a little bit more clear. So I wrote this sample app for Android, and I put the code on GitHub, but I'm only going to go through a few small chunks of code because I'm using a big font. So here's the method. This is our system under test. And I'm going to walk you through this real quick. The first part, we have this device object where we check if location is enabled. That should look familiar from one of our earlier examples. If location is not enabled, then we call onLocation unavailable and get out of there. So I'll get into that first. But before that, quick overview of the second part. If location is available, we skip that callback. We call start updates on this client object. And that starts spitting out values into our callback here via the onUpdate method. Sorry for the naming location curloc. That means current location. Didn't want to make the font too small. Got to fit it on the screen. But curloc is current location. Last loc is the location of that was given on the previous call of onUpdate. So this is kind of a common pattern of like caching the last thing and then comparing it each successive call. So we'll get into that first chunk first. So try to memorize like those 3 lines. If device.isLocation enabled, callbacks.onLocation unavailable. So for the client, the part that we're not using, see the client stuff doesn't start until after that return. So we want to pass a dummy because we don't want to use it. And this would be passed in the constructor of the class. So this dummy just throws an exception when we call start updates because we don't want to use it. Just to reiterate, we're testing the first part, so we don't care about the second part after the line break. So that client part is completely irrelevant, and if we get there in our test, that means we've done something wrong. So we throw. The device part, where we check if location is enabled, we want to test that onLocation unavailable is called when location is not enabled. So we can pass in a stub. This is a hand-coded stub that returns false. So that's pretty simple, and this is what our test looks like. Sorry, that's a lot of code. I'll walk you through it. Device info, no location device is the stub that I just showed you in the previous slide. The dummy client is the thing that throws that we don't use at all. Callbacks, we're going to create a spy with Mockito. So we're going to observe and verify. And then we instantiate our system under test, which is location change tracker is just the class name for the class that method I showed you is in. So we pass 3 things to the location change tracker constructor. First is this device info, the stub. Second is the dummy client that we're not going to use. And third is the spy of the callbacks. So we exercise our system under test, tracker.trackLocation, and then we verify that onLocation unavailable is called. So I'm just going to step back and make sure that looks right. So we pass a stub for the first thing, a spy for the second thing, and a dummy for the third thing. And that should pass. It does. All right, second part. This is a little bit more complicated. We call start updates on a location client, and the callback that we supply to that call has a method onUpdate, which gets called with a location. If it's not equal to the previous location, then we use our other callback that's supplied to this class to call onChange because the location has changed, if that makes sense. If it's different than the last time, it's a new location. Otherwise, the consumer doesn't want to know about it, so we ignore it. But we still store the last location every time. So let's get into that. We need to create a fake for the location client. So that's what this is. Similarly to our in-memory database, we can use just a regular Java data structure instead of something where you might, like in real life, you'd be polling some GPS client and getting updates like every 5 seconds or 10 seconds or whatever. But in this case, we can just preload it. So in the constructor, we just pass a bunch of locations. We add them to this collection, this locations array list. And then once we call start update, we just spit them back. So there's nothing asynchronous about this. We're just expecting this test to be fine in a synchronous manner. If you wanted to, you could do some extra stuff to make it async, but that doesn't matter. It's not really going to affect the behavior of the system under test. And then we can just ignore that stop updates thing since we're not going to call that. I suppose we could throw, but I couldn't fit that on the screen. All right. Secondly, this should look really familiar. This is another stub. Maybe I should have used Mockito just to show you the 2 ways to make a stub. I'm sure there's more, but I hand-coded it anyway. We return true this time, and I call it location-enabled device because it's simulating a device where your location is always available. And this test looks pretty similar. We still have that stub device that always returns true. And then we create our location client. In this case, last time we passed in a dummy that always throws. In this case, we're actually creating an instance of this guy. So we're passing in some locations. Pretend those are GPS coordinates. I mean, they kind of are, but they're simpler. And you'll notice the second 2 are the same. So jumping ahead a little bit, we're going to want our onLocation changed method to be called just twice, not 3 times, because it only changes once. So we got the first location and the second location to be spit out, and the third one we can just ignore. Our third Testable is this callbacks class, or interface, sorry. So we create a spy with Mockito. Again, sorry about that mock word, it's a little confusing. We instantiate our system under test using our 3 test doubles, and then exercise our system under test by calling track location. And then we use verify, which is Mockito's API for checking spies. We verify that, so this is a little backwards. We verify that onChange was called with a location 2 times on the callbacks object. It's not my favorite API, but it works. So let's see. Here are a few extra considerations. Stuff that I didn't mention, but also pretty relevant to using test doubles. Testing behavior versus testing state is kind of a hot topic. Maybe not anymore, but it used to be. Martin Fowler's article that I stole that quote from earlier is called Mocks Aren't Stubs. You might be familiar with it. He goes into this a lot further. Basically, some people think you should be testing your class's behavior. Some people think that you should set up your system under test in such a way that you can test its final state, and that is somehow a better indicator of your class working as expected. Quick example, in this case, instead of using a spy for our callbacks object to make sure that onChange was called, we could have supplied a fake instance of callbacks, and then in that instance we could like increment a counter. If you imagine like an integer field in our callbacks implementation, we increment that every time onChange is called, and then we have a getter like number of times onChange was called. I'd be very verbose, but that's what it would look like. And then we could just assert that the callbacks instance that tracks number of calls, we could just assert that that number is equal to what we want to. In this example, there's not really a huge advantage to this like state approach versus behavior. The spy is pretty straightforward. I usually use spies. I don't really do much. I don't really use fakes much for asserting final state of a system, but lots of people do. And if you want to read more about that, I recommend Martin Fowler's article, Mocks Aren't Stubs. I'll put that in the final slide. Second extra consideration, test doubles aren't just for unit tests. I mentioned this on the title slide. Where I work at American Express, we use Espresso a lot, which is a library for testing your app's UI. So you actually like tell it to click on buttons. And we supply lots of doubles for stuff like web services. We use WireMock a lot for like a fake web server. Although WireMock, it might be a little bit of a gray area between a stub and a fake. I guess it just depends on if you can, for example, like if you could do a post to a fake web service and then do a get later, and the get would change based on your earlier post, then I would call that a fake. But if it's just canned responses, I'd call that stub. Third, dependency injection helps. I'm not going to get into this much, but you saw I was using lots of interfaces, and our test doubles are like alternate implementations to our interfaces. So anytime you're relying on interfaces and there are multiple different implementations that you might want to use in the course of in the code that you write, you can either do stuff like use factories, abstract factory, factory, a lot of stuff like that. I use Dagger myself. At the company I work at, we use Dagger extensively. It's good for providing alternate implementations of interfaces. Sometimes you might write a fake and it's so good that you just want to use it in your app. Sometimes maybe that could happen. Just a thought. And finally, it's okay to write tests for your test doubles. It's okay to, so it's like testing your tests, which sounds crazy. But say like you have an app that depends heavily on a database. And so you write this fake database that you can use in all your tests. And the fake database has all this behavior that emulates a real database. But you want to make sure that the fake database works so that you can rely on it. So rather than just crossing your fingers and hoping that that all works as expected, you can actually write tests for your test doubles. But if you have to create test doubles for your tests to test your test doubles, then you should probably stop there. Last slide. I'll skip to the second part, a few more resources. I already gave you the URL to my GitHub project, which is where all the sample code lives that we just went through, the location stuff. Mocks Aren't Stubs is a good article by Martin Fowler. Early 2000s, but still relevant. And the inspiration for this talk was a talk by this fella, Dave Marshall. He gave this talk called Mocks Aren't Stubs, Dummies, Fakes, or Spies. The language that he used in that talk was PHP. It was at like a PHP Symphony conference. But same concepts. And the book that I mentioned in the beginning is called X-Unit Test Patterns, written by this guy, Gerard Meszaros. And I could be wrong, but I think he can probably be credited with most of the vocabulary that I presented in this talk. Then we got email, Twitter, blog. I don't write much anymore, but I used to. And that's it. So I think we have some time for questions. It's only 7:47. So thank you all for coming. Yeah, shoot.
What practice do you follow to keep stubs from getting stale? Like using something like VCR works great in Ruby until the API that was supposed to call changes, and now your stubs are no longer valid.
Right.
What do you do for that? Do you refresh them like periodically, or how frequently would you?
Yeah, you have to refresh them. Luckily, at Amex, our APIs don't change much. It's mostly like read-only stuff, providing users with information about their credit cards. But yeah, anytime the API changes, you have to re-record that stuff if you're using VCR, or like manually edit it if you're using JSON or something. And that's, for us in our process, that's always part of the pull request. Ideally, if you write new code, there should be tests for it, and those tests should run in your CI environment, whether that's Jenkins or whatever. And if you don't update your stubs, then it'll fail, so you have to. Yeah, do you have any ideas for how to keep that stuff? Yeah, I agree that it's not very fun, and manually editing XML or JSON is not the most fun thing. But yeah, that's tricky. Yeah, anyone else? Yeah, shoot.
So I apologize if you actually covered this. I had to step away during the slide on Spies to let someone in. So I use Clojure in my Google Clojure in my personal project as well as here, and the mocking system in that, I'm trying to figure out. It seems to me like it lives in a gray area between mocks and Spies. Do you know if that's true? Do you know enough about Clojure's mocking system?
No, I've never used Clojure at all.
Okay, so the patterns for that one is you can basically mock an object, mock a class. You actually pass it in an instantiation, and it mocks it.
Okay.
Then you can define kind of like mocks up front, what methods are going to be called, run it, but then you have to say replay, run, and verify on the thing. So it doesn't do the verification until the end, and it also gives you a way to say this method can be called any number of times from 0 to infinity.
So it's more flexible. Or it's not flexible. You specify the number of times.
You have to specify. Well, so you can specify it's going to be called an exact number of times. You can specify that it will be called at most once.
Okay.
You can specify any time. There's an actual tag any times.
Yeah.
That says, I don't care how many times this thing is called.
Okay, so I haven't used EasyMock for Java, which is kind of a popular mocking library for Java. But it sounds like what you're describing is probably more flexible.
Okay.
So the word verify tips me off to spy.
A little more on the side of the spy.
But expect and verify, I'm not sure.
Yeah, because it has both. You can define expectations, and when it almost feels like it even pulls in fakes, because when you're defining expectations, you can also say that when this method is called with these parameters, it will return this value.
Right. Yeah, Mockito has that too.
Mockito does a lot of that.
Yeah.
Where he makes a whole lot of these concepts.
Different paradigms.
Yeah, it's definitely a gray area. An object that you create with Mockito can be both a stub and a spy. And I think you can probably do expect with Mockito also, but I'm not sure. I've never done that.
Okay, so it sounds very similar to Mockito's.
Yeah, and you can create kind of elaborate stubs that are probably more like fakes. Yeah. But yeah, thanks for bringing that up. Yeah, shoot.
How much complexity, it's kind of a hard question, I guess, to answer, but what's your gestalt in terms of how much complexity in terms of your setup or tear down of your test should be in terms of mocks? Because you get into a situation where you've got mock this, and then you've got another layer, and you're mocking a few more things.
It can be pretty complicated. Yeah, at Amex, I'll just throw this out. I'll probably say 30% of our development time is done writing tests, which is probably on the high end for most people, but maybe not. I think it's worth it, especially with stuff like WireMock and Mock Web Server. That can get pretty messy and tricky. And if you're using that and like mock objects, then you have like all sorts of test doubles floating around and lots of setup that goes into that. You can kind of delegate a lot of that to like helpers that will get your system in the correct state before you actually test anything. Ideally, your like test method shouldn't have more than a few lines of setup. But yeah, it can be a lot, certainly. Yeah, what's your experience? I'm not sure what that's like for other people.
Yeah, I'm not sure I have a great answer either. It just seems like sometimes
I will
it's
say,
hard
like,
to separate
what
some
we
of the
do,
dependencies.
we found that if you don't go back and do a lot of, tear down and clean up, clear out queues, reset mocks, all that sometimes when you run your test over and over that, you'll get bad results.
Right.
So we just kind of implemented something where we had to, just clear out all the, recreate all the mocks and clear out all the queues and everything so you won't get all hosed up.
Yeah, I think using like handwritten fakes can be a little bit easier to debug when stuff goes wrong. With Mockito, you can't really like inspect the state of your doubles. You kind of just call this stuff on it and then cross your fingers, hope it works. And if it fails, it's really hard to debug.
Yeah.
Do you have any tips for testing the actual behavior of the code that you've written? I mean, are you always just asserting on the return values and side effects, or are there other approaches?
Well,
For testing behavior of the code, that's probably more similar to like the spies and mocks that I covered, where you're verifying that our particular method is called. And you can be more explicit, more strict, like this has to be called before this. But yeah, I mean, it's tricky to like be this omniscient third party sometimes. Yeah, does that answer your question?
Yeah, calling the order that
Right.
they're called is important using Spies.
Yeah, so I think Mockito gives you a lot of tools, EasyMock to assert order and values. So in one of my Mockito examples, I said verify that this method is called with any instance of a location, but you can also make sure that it equals something. There's lots of these matchers in Mockito.
anything else? Yeah.
Should test code ever exist in source code?
In my opinion, no, but sometimes there's a gray area. For example, maybe you need to refactor your source code to enable testing, and that's fine by me. If anything, that's good design. Like, say you're relying, like I mentioned right in the beginning of the talk, if you're relying on like a concrete class, so an implementation of a class with like real methods and stuff, and then you want to write a fake, but you can't because it's already there. Maybe it's final, so you can't override it. It's really good practice to extract that into an interface that defines the exact behavior that your code needs. And then you can use that interface in your tests. And then maybe down the line, some other piece of code that you're writing or some other new feature that you're building, you're going to need to provide an alternate implementation for this interface. Trying to think of some more examples. It can also be a bit of a gray area. Like with Android, you have build flavors. So you can have like a debug-only build versus the release build that goes to the Google Play Store. And in lots of apps, and in the app that I work on, we have tons of code that only runs on debug builds. And in a way, you could call that test code. And our tests do run on the debug build flavor. So yeah, there's tons. I guess one example would be like Stetho is this Facebook library that inspects all your HTTP traffic. Scalpel, I think, is a Square or a Jake Wharton library that like shows a grid overlay on top of all your views. Something I'm working on now is like having a feature toggle, so you can flip a switch that's only available in your debug app, and then it'll provide alternate implementations of some dependencies, like for example, like a new API version. So if you're developing this big feature and you want to be able to do a bunch of pull requests and merge your code into the main branch, like if you're using Git, for example, but you don't want it to be like in the release build, you can do all kinds of weird stuff with your build variants or build flavors in Android. I'm not sure if iOS has that, but yeah. So yeah, gray area to answer your question. Yeah. Anyone else? Suppose we could wrap up here.
Do you ever use Spies to do like stress tests?
No, I haven't. We did do a lot of stress tests on mobile. I know our backend team does a lot of that stuff, so they probably do. I'm not sure. Is that something you've done? No. Yeah.
You could do it a hit.
I'm not sure. Yeah, if you wanted to like monitor the number of calls in a certain period, yeah, that'd be a good usage for Spies. All right, it's about 8 o'clock, so I'll stop here and turn it over to Chuki.